In this problem, I want to determine the magnitude that this person puts on each handle. There's two handles there. I want to know the force he puts on each handle, knowing that the wheelbarrow and all its contents have a mass of 60 kilograms, and that acts right at point G here at the center of gravity. Okay, so again, as with any equilibrium problem, the first step is to draw a free body diagram. Okay, so again, we have the weight right here, which is the mass times gravity, so 60 times 9.8, acting straight down at point G. Okay, I have a reaction force at point A here, and that's acting straight up. That's the normal force acting at point A. And then I have the forces Bx and By acting at B. And there's actually, again, there's going to be two forces, because one on each handle. Okay, so from that, I can sum the forces in the x and y direction, setting them equal to 0, and summing the moment. So we'll start with summing the forces in the x direction. The only force in the x direction is the force at B. Okay, so for it to be in equilibrium, that force then has to be 0. So there's no force in the x direction. Now I'm going to actually do the moment equation next, and we're going to sum the moment. Again, the best place to sum the moment is about the point where you have the most unknown forces, which is point B in this situation. Okay, so Bx and By create no moment about point B. The only forces I have, moments that I have about point B are Ay, and again, that's going to be a clockwise negative moment. Okay, 1.4 meters times Ay, and then a positive or counterclockwise moment of the weight, which is 0.9 over times 60 times 9.8. Again, that's positive. So from that equation, I can determine what the normal force at A actually is, which is about 378 acting at A, from the moment equation about B. Okay. Now that I know that force at A, I can now use my last equation, which is the sum of the forces in the y direction, which I have, again, that normal force Ay, the 378. I have the weight, which is negative 60 times 9.8, and then plus 2 By, because remember, there's a force on each handle. That's where the 2 comes from, By. And those are my forces in the y direction. So then solving that equation for B, I find that each handle has to have 105 newtons acting on it. So again, free body diagram, sum the forces in the x set it equal to 0, sum the forces in the y set it equal to 0, and sum the moments about any location, generally the location with the most unknown forces going through it, and set that equal to 0. Then solve those three equations, and you can calculate out what you're looking for.